Hi everyone, and welcome back to part 2 of the DIY custom keyboard series of videos which I'm going to be doing, and we're going to get straight on with it here into machining as we did enough CAD and CAM in the last video. First toolpath you can see here is just using a chamfer mill, which has got a nice sharp point on the end, just to put a 1mm hole or punch, if you like, into the surface of the acrylic, so that the next operation, which is a 2-flute twist drill, standard, HSS twist drill, doesn't go wandering off when it plunges into the material. And one thing to bear in mind here is that all these tool paths are essentially set for aluminium, because that's what we'll be using to cut the first plate out. I'm also going to try a brass one as well at some point. Might not be this particular keyboard layout, but yeah, we'll set up for aluminium. Therefore, most of the tool paths are a little bit slow for acrylic. Some of them are okay, but some of them are a little bit slow. So you can see there's just a tad of acrylic swarf build up on the drill there, which you wouldn't get if you were using the right feeds and speeds for acrylic. Okay, so once those holes are drilled, we can get into doing the cutout. But you'll notice I've used those drilled holes, and the reason I did that toolpath first was so that we could put some more hold down screws into the actual part, so when we do a cutout, which is the operation we're performing now, it doesn't break free and end up not where we want it, which is still in the machine. So we're using adaptive here. You can see that's plunged down 3mm into the material, and now it's started to do the trochoidal toolpath to run around the edge. I'm not going to use slot milling probably ever again where I can help it. Obviously there's some places where you can't help using slot milling, but certainly in aluminium, which this will be, or possibly brass as well, the slot milling is just brutal on tools and the machine. This is a lot gentler on the machine, and you can see the real-time close-up shot as it comes around the bottom of the piece there. Fairly decent chip spray there. Could maybe, well, if it was acrylic it would be faster, the final piece, but as this is a test cut for aluminium, then this feed and speed will work out fine. You're getting some decent chips out of there, and it's pretty smooth actually. But not quite so smooth that we don't need a clean-up pass, and this is what this one is doing, which is just a contour around the edge of the piece. It's taking off 5mm, which I left on the previous operation. Sorry, not 5mm, 0.5mm, which I left on from the previous operation. It was just taking off any scallops which the trochoidal toolpath tends to leave on the edge of the piece that you're milling out. Okay, and once we've got our piece, which is essentially just the dimensioning, we can now get on and do the actual main milling itself. Now this is going to be again adaptive milling, and we're using a 4mm 1-flute cutter. Now I do have a 3-flute roughing 4mm end mill, and that works okay, but I've got a really good recipe I find for a single flute cutter, so I'm going to try that first. And you can see it starting off with the first of the key pockets for the actual keyboard keys themselves. You see it ramping in there, and then it starts widening that circle out, and then goes into the corners of each of the each of the pockets. Again, the feeds and speeds on here are probably a little bit slow for acrylic. It would probably go a lot faster if that was going to be the final material, but again, this is for aluminium, so we're just testing this both to make sure the dimensions I've put in the CAD are correct and that the keys fit, and also just to test the overall toolpath, just to make sure there are no errors in it. Now this piece seems to be fairly orderly, and you can see it's kind of working its way from one end of the keyboard to the other. It's just gone past, and we're machining on the back here as well, so it's just gone past the number pad, the cursor keys, and now you're into the return key and the keyboard keys, you know, the QWERTY part proper. Quite a long toolpath, you know, there's 405 of these holes it needs to cut out, and it needs to make 2 passes. You can see it running back there, so it's doing the kind of first level to the bottom of the 3mm pocket, and then it's doing the step at the top. Okay, that's nearly finished, and the next toolpath we're going to be working with is the one I've probably got most concern about at the moment, because it's using a 2mm 2 flute cutter. No, it's a single flute cutter, apologies. So a 2mm single flute cutter, which means that we can get a 1mm radius in the corners, which is going to be better for the actual keys, because they've got a small radius to them in the corners, and obviously you can't have a radius that is too large, otherwise they won't fit properly. This was a very long toolpath, because essentially it's running a pretty delicate tool into, or what will be, aluminium, and therefore even on an aggressive strategy, I think G-Wizard was only giving me something like 600 or 800 millimeters per minute. Again, it's adaptive, and this is also the other reason I kept it fairly light here, is because, as you can see here, we will be doing a 3mm depth of cut in places where we couldn't fit that last 4mm tool, and this is one of those areas. So there's the slot that runs either side of the space bar, which then goes down to 2 pockets for the stabilizers, and in fact any of the oversized keys like return and enter, the plus on the keypad, you know, the 0 on the keypad, they all have little stabilizer bits on them to stop them rocking when you hit them off center. Still, we're getting some nice chips out of that, and that's encouraging, so I think we should be okay for aluminium on those. Obviously I'll be running the mist and cooling solution. And a quick step over to have a look at the Mach 3 actually running through the toolpath. You can see we're about, what, a third of the way through, and we've already done 60,000 odd lines of G code. Oh, and the other thing I did on here as well is, you can see I've used the feed override actually to bump the feed up to 150% of what it is normally. And went even further. This is near the end of the toolpath. You can see there about 200,000 lines of code it's run through, and I've bumped the feeds override up to 200% manually, just to get it to run a lot faster than, because it's in acrylic, not aluminium. And there we go, we're finished. That took about an hour and a half, 2 hours I think, for that particular bit of the toolpath, so quite long. And here's the result. So back into the workshop, the main bit of the barn, and just a quick test fit with some Cherry MX Blues, which is what I'm using in this keyboard, just to make sure they fit into there properly, and they fit absolutely perfectly. So there we are, we've got a successful test cut, and we'll be going into aluminium next. So as ever, thanks for watching, and I'll catch you in the next video of this series.